Greetings to the participants in the 2020 Virtual Tri-Society meetings. My name is Will Brinton. I am the Director of Woods End Laboratories, and my co-presenter in this topic is Elliot Coleman, Four Seasons Farm in Harborside, Maine. This presentation is part of the overall session titled Soil Biology and Biochemistry, Soil Carbon and Nitrogen Cycling. I want to first say something about the author's enterprises. Woods End Soil Lab, founded in 1975 to explore soil testing methodology which helps reveal biological soil fertility. Four Seasons Farm, founded in 1968 to develop organic, sustainable, multi-season production of vegetables. We are very pleased today to have this opportunity to contrast our timelines with this technical subject. We present today thematically a meta-analysis, a review of literature consistent with our organization's time tracks in soil methods and practices. A focus, we select CO2 respiration, a suitable soil analysis linking management to soil biology activity, also fitting framework within organic farming. Our hypothesis is that the emergence of organic biologic farming, particularly after the 1940s, exercised a strong role focusing science attention to soil measurements. The overview today shows numerous farm system comparisons in the years of the 50s through the 80s, which acted to validate analytical methods and provide linkages to soil biology. Let me first mention the summary timeline that I will be covering in this literature review. We start in the 1920s when some of the most basic work on soil CO2, plant climate, carbon cycling was performed, and we select an example from Sweden of Lundegårdh's work. In the 50s, we see emerging a strong analytical component of CO2 method development and excellent analysis of factors involved. In the 70s, we see it all coming together in system comparisons where organic farming science begins to focus these method pursuits. Later, and not so much covered in my presentation today, we have a shift, particularly in the United States, to alternative farming and then to soil quality. And very currently, we see a shift to generalized soil health. I want to start with Lundegårdh in Sweden, whose contributions reach back at least to 1922. On the left side of the chart here, I show a flow form that Lundegårdh published in 1926, in which he describes three primary effects, you could say physical, chemical, biological, of soil management and fertilization. On the left, he described the salt factor, which is salts and nutrient effects of fertilizer. Heavy fertilizer, also points out, has a stimulation of soil organisms. That's the biology component. And finally, he emphasized the eventual change in physical structure of the soil that results from these management practices. Underneath biology, he subdivides it into two categories. It is clear that his innovations covered many areas. One is just the good basic work on CO2 flux and soil diffusivity of CO2. Another one is he clearly links CO2 quantitatively to plant carbohydrate assimilation, in a way beginning the first climate plant soil interactive studies. His concept of the CO2 factor is very intriguing because in a way it expresses the feed the soil view that came to be a hallmark of organic practices. He also was critical of the narrow focus in science on what he called direct fertilization. This is where we only look at nutrients and not biology. Incidentally, on each slide here, I have relevant key literature with which you can find these citations and documentations. In the 50s, we have this surge of methodology contributions. We can focus on Hohenheim University. Both Isermeyer and Kerp, present there, produced the first standardization of CO2 capture methods, basically base trap methods. These are still cited today. They also conducted detailed examination of the sources of variability, namely soil mass, soil moisture, and temperature influences. Incidentally, Stevenson in Canada and Kerpf in Germany observed CO2 bursts simultaneously or one right after the other, and prior to Birch observing and reporting it later in the 50s, today the CO2 burst is largely called a Birch effect, attributing it to the British researcher in Africa. We also found evidence that the soil health concept was clearly proposed between 1976 and 78, and consonant with that was soil respiration as a core method. I want to draw attention here on the right side to an early graph published by Kerpf in 1954, outlining day-by-day CO2 respiration of soils and the impact of drying in creating the CO2 burst. One of the things that we are all familiar with is this day-by-day progression of respiration. Today, unfortunately, we have these debates. Is the first day relevant, or is it the third day, or is it the fourth day? And you can see this is a consistent pattern, and we might conclude that basal respiration, which is the steady state after this drop, might more likely represent normal soil conditions. But because soils are taken into labs, dried and prepared, you're going to have to reckon with some kind of drying, rewetting phenomena and a burst, which they outlined here very clearly. Still controversial today is the impact of soil handling and the influence of moisture. On the left side here, I pull a very significant table or chart from Craswell and Waring's 1972 publication, in which they examined how different grinding and size ranges of soil will influence the disruption of soil organic matter and the net release of nitrogen in a mineralization incubation assay. Notice that when you subdivide them by soil groups, the large differences that are evident, and they acknowledge that some workers, depending on which soils they choose for the study, find no differences between methods, whereas if you examine them all, it's pretty apparent that grinding and sizing soil in a laboratory is going to have a large effect. Another very interesting finding is from work published in Switzerland by Yegi in 1976, where he describes the inhibition mechanisms causing overwetting of soils. And here, I took a picture from one of his reports, are 4 different scenarios of how we conduct CO2 respiration. And in scenario C, he attempted a capillary wetting from underneath. This is very similar to the method known today as the capillary or the Haney method. And he particularly found that this consistently caused overwetting of soil and wrote recommendations on how to avoid that. The big linkage came in the 70s when the impact of soil management was examined in terms of carbon dioxide respiration and other associated indicators. What happened was that the growth in Europe of biofarming triggered a study by the German Ministry of Agriculture in the years 70 to 74. What they did was they selected 9 farms of known biological management history encompassing 15 to 25 years, and they paired them carefully with similarly structured conventional farms. They then initiated a process of selecting soil indicators by a stakeholder process in which all the groups were involved in selecting physical, biological, and chemical methods. I just want to highlight a few of the interesting results of that study. On average, the results of biological versus conventional soil management indicated carbon dioxide respiration rates of 10 to 50% higher, 14% higher NMIN, 40 to 76 greater enzyme activity rates, 4 times higher azote factor counts, and up to 4 times greater earthworm counts on these biological managed systems. Incidentally, these findings stimulated many other similar studies over the next 40 years, well known as, for example, the DOK studies in Switzerland and Uppsala studies in Sweden. To come to a summary and conclusion, our timeline and our review of literature has shown that early visionary farm practices strongly propelled scientific innovation with regard to biological indicators, especially soil respiration, but also healthy soil concepts, and also the development of microbial indexes. The concept of physical, chemical, biological is clearly traceable to the 1970s, if not much earlier. This is very interesting to us because many people think this is something we have just arrived at very recently. If you stand back and look at the literature and the punctuation of reports and so on over time, the innovation over time appears to be in fits and bursts, or a pattern of that nature. Slow punctuated advance with evident reinvention and rehashing right into the present. Factors in this that could easily explain include language and technology barriers in literature. For example, I've had to review documents published in German, Swedish, and French in drawing this literature trail. There's also presently the need to satisfy broad industry stakeholder base, and we feel that this is creating a standardization pressure, which can influence the objectivity of the science. And there's also evident a bias against organic farming core concepts, which could explain some filtering of methodology that is going on. We want to thank you for attending this session and want also to ask you to please contact us with questions and comments. Thank you once again.